passing through the CESS system. We will install the async OS. We install the license key. Then it was configured as a transparent mode so that the data can be passed through the license key. It was configured transparent mode. I am hearing echo.
Yeah, I'm hearing echo.
Hello, is it okay now?
Yeah, continue.
Okay. So, so we configured WSA in a transparent mode so that traffic can pass through without hampering the users. And initially we redirected the BDN server traffic only through the Cisco WSA. So this is our network architecture on how we actually deployed the CESS. So if you look at the right side, so we deployed the CESS in the cloud, in the BDN cloud after the core switch. So our initial design was to install it before the core router. But because they already have the data center and it is supposed to be deployed in the cloud, so we had to set it up in the cloud as well. So that also gave us a challenge because in this route from core router to the cloud, the traffic will be doubled because it has to be rerouted, all the traffic has to be rerouted to the CESS, then it will go to the client routers. So that is one of the challenges that we are still working on. So while deploying it, there are various challenges that we had to face. The problem was initially we had the network traffic diversion was not ready at the BDN side. So diversion of web traffic, it created a very high volume of data, and it actually hampered the BDN traffic, causing the servers to go down or the network to go down in several cases. So that was one of the considerations that we had to take on. And we also needed WCCP support in the device, which also posed a challenge to us. Later on, after the deployment, what we found, the software repeatedly started hanging. So after running it like 2 days, 3 days, it becomes unstable. It doesn't work until it is rebooted. So while troubleshooting with that, we had to take help from the Cisco tech team, which are based on India. So because we did not have the local tech team, it took a lot of time from us. So anyway, so I think over the period of 2 months, we solved the problem. So there is a bugs in the system. They had to update the system. We have to update the memories. We have to, in some cases, I think, reboot the software several times. Also update the ESXi version of the VMware as well. So after that, I think we got it working in August 2019. So from that on, we started getting the data. So this is some average statistics that we received from the system. So average transactions are 273 per second. So this is kind of old data based on October 2019 data. So this is transaction means number of packets. How many packets are passing through this CESS system. And we had 24 megabits of transaction per day. So maximum we received in this period was 730 per second. So average bandwidth used was 27 Mbps, and maximum we got was 1.2 Gbps. So average connection was 6,000 plus, and maximum during attack period, we'll show it later, we got a maximum of 33,000 connections at the same time. And in this period, we got over 270K unique users. So by users, we mean IP addresses. So unique IP addresses was counted during this period. So in terms of IP address, so top users was from France. There's 4 instances from France that uses high amount of bandwidth. So later on, all these IPs were actually connected to an attack as well. There's some IPs from US, Germany, Japan, and Russia. So in terms of transaction as well, we had the top transaction were from France. Then we had Germany, Netherlands, US, and Bulgaria as well. So let me give you an overview first how the system works. So for detecting different kind of malwares, so, and virus and all those things, so they apply a mechanism called web reputation filter. Okay, so what it does, it uses different kinds of scoring, different kinds of properties to generate a score for every website or every IP address. Okay, so it could be domain owner, hosting server, the time the server has been created, what is the type of the site. So based on this score, the site can be blocked, allowed, and delivered. Okay, and this is configurable. So we can configure the which part would be blocked, which part would be allowed. So this is what we applied in our case. So in our WBRS, this is our access policy. Okay, so the reputation score could be between -10 to +10. So this is the range of any reputation score. Okay, so they have an algorithm to calculate this. So what we configured is if the reputation score is below -6, it will be blocked by default. So that means the data will not be passed to the users. Then if it is between -6 to +6, then it will be scanned further, whether it has any malicious data in there. And if it is +6 to +10, then we allow it by default so that it will go through without any further scanning. So this is our configuration, but you can change it if you want to. Okay, so this is how we categorize, and when we block and when we scan, then we can identify different types of malwares in those packets. So this is the data for October. So in this case, we blocked size was 11.6%. After scanning further, so remember, so between +6 to -6, we scan everything. So after scanning further, only 0.05% were detected as malware, and the other 80.54% was detected as clean, which is 568 megabytes. So million transactions, not megabytes. And 55 million transactions were termed as allowed as a non-malware traffic. Okay, so this is for October. So when we move on to November, if you see the traffic is increasing over time. So in October we had 760 million transactions. In November we had 931, and we had 33% of the data was blocked. Then in December we see 32% of data was blocked, and you see a total increase of transactions is also almost 50% to 1437 million. Okay, so similar trend we see. So as the blocking percentage is increasing, we see the scan clean further is decreasing. So initially it was 80%, then we see 60%, then again 61%. So then in January we see the blocking percentage went up to 48%, and the total transactions went over 2,000 million transactions in total. So in February, the last month, this is again, we saw a degrade of data. We see less amount of total amount of data. We see block is 10%, and the clean rate is 80%. So if I summarize all these things together, we have the figure shows up to January. So you can see the block percentage is increasing over the time. Okay, so this means basically two things. One is over the time, because the traffic is increasing, so we detected more amount of attacks into the system. As there are more attacks, that means your block amount is also increased in the system. So later on, we'll show in every month what type of attack we detected in various categories. So this is for February, the summarized data. So we have 10%. So in February compared to January, we actually had less amount of data. So that means we had actually less amount of attacks as well. So this is for the four scenarios. So we have blocked. So in the first part, you can see up to October to January, it decreased a lot. Then we have a decrease again in February. And in scan further, it is also increased in every month. And for the allowed scenario, it is also increased as the traffic increases. So what's important here is to understand that the traffic is increasing every month. Okay? And as the traffic are increasing, that means there are more amount of traffic of attack data is also found in the data. Okay? So this was web reputation. So if I look into the block traffic, so this is for different months, the amount of blocks traffic. So this is where we are showing in the x-axis, we are showing different days. Okay, so different day of the month. So we have data for 5 months, October to February. So as you can see, it is not a like symmetric graph. Okay, so it changes a lot. So that means it's not like every day we are having the same thing. It's not like that. So when you see a spike, like if you see there is a yearly spike in January, in like I think 17 or 18 of the month. So there is a huge spike of yellow. So that means there is a huge attack coming into the system from different IP address at the same time. Okay. Then we see another attack in the January as well in 24th. So in terms of if you look at December, the purple one, we see on the 28th there is the attack. So this attack actually dominates the whole scenarios. Okay. So in regular case, if you look at the first parts, so you see there's average traffic is very below. Okay, these are like regular traffic. But as soon as there is attacks coming in, and attacks is coming in from different sources, and when there is attack, we see a huge spike in amount of traffic data as well as block traffic as well. So these are the data that is blocked. That means they are not actually passed through to the users. They are blocked at the CESS system, and that means the attack was not could not reach to the end user at the end. So this is malware detected by scanning. So the one that I showed before, so this is blocked by default. That means the reputation score is below 6. So if the reputation score is above -6, then we have to scan it further. So after scanning again, we detected some attacks as well. Okay. So in this case, because we had in January, we had a huge attack, which I think around 10 million. So because of that, the other graphs shows almost to 0, but we actually had attacks in those cases as well. So what it means is that after detecting our scanning in additional layer, we are able to detect additional malware traffic as well. Okay, so that was one of the findings that we had. So in terms of this is a little bit details of malware detected. This is from October. So this is by second scanning. So in October we detected, at most we detected 40,000 in one day after the second scan. Okay. So this was clean traffic by scan. So this means after the cleaning, the traffic seemed valid, non-malicious. So that was passed to the user. So as you can see, there is actually no real similarity here on how they are related. So as there is more data, they can be passed through as valid, or they also may be detected as clean as well. So these are 5 months scenario that we saw. So in the February case, so this is interesting. So if you look at the green line, so in February there are a lot of data that is passed as valid and after the second scanning compared to other months. Okay, so so what it also means is that once we have the data, that means there are more, the reputation filter may be applying more more filters in there, but after second scanning, after analyzing the data, those data seems to be clean to the user. So this is the allowed traffic. So the allowed traffic means it is allowed by default. So that means there will be no further scanning because the reputation score is above +6. So it will be passed through without further scanning. So here as well, there is no real matching pattern that they are related. So it's also basically they are related to the number of data that comes in, and a percentage of those data is actually passed through as clean data. And what we see is that this trend is always below 10% of the whole traffic. So this is the total comparison of all the 4 types. So we have for the 5 months, we have the total traffic. So as you can see, you have very high traffic in terms of profile traffic. We have January, we have February, and other 5 months. Okay, so for all traffic, we have some data for, this is for the 4 types. So this is for October. So as you can see, as the data increases, the allowed is almost always the same, the green line, but the red line, it is when there is attack, the block traffic increases, and when there is no attack, it remains low to the baseline. So this is the similar trends for November, and this is for December. So in December, as I said before, we had a very large attack at the end of the month, around 28. So that gave us a huge spike of block traffic, the red line, at the end of the month, which also causes the total volume of data in that month. So that attack actually had over 160 million of transactions in the same attack. So this is in January. So in the January as well, we had 2 major attacks in mid-January and also in the 4th week of January. So in February, we see one attack in the middle, that is in the, I think, 15th. So another interesting thing here is that in the 12th or 13th February, there is spike, but those are not actually detected as an attack, because most of those traffic are deemed clean after it will scan through. So that is something new that we have seen in this month. Usually what we see when there is a spike, if you look at the previous scenarios, when there is a spike of data, so usually it is blocked because there is an attack. But in this case, we see a non-attack scenario, but there is a spike as well. Okay, so this is reputation score for October. So just showing you example of different scenarios. So the first 4 lines, so these are the blocked by default because they are below -6. And if you look at the last 5 lines, so these are allowed traffic because they are greater than +6. And everything in the middle, they will be scanned further, and after that they are cleaned or malware is detected. So this is the similar data for October, November, January, and February. So, so this is the statistics for scan further and scan. So if you look at the red line, there is a scan further. So it shows the red line. So over the month, the blocked amount of data is almost very similar. So very less amount of data is detected of the block, and most of the data is actually detected as is passed as valid data or clean data after scanning. And also we can see the amount of data is actually increasing as the month goes on, which also suggests that we have more amount of data that is coming into the system. That means more amount of data will be scanned and more will be passed as clean. Okay, so let me move on to the different types of threats that we detected. So these are the major types. So we have the botnets, we have different type of exploits, we have the malicious sites. The major 2 cases was malware sites and phishing attempts. So these are the major 2 scenarios. So for the phishing, we had over 48 million, and for the malware side, we had almost 33 million of attacks. So compared to others, we had also spam, we had spywares, but they are actually very limited compared to phishing and malware side attacks. So this is for October. So as you saw already before, as the attack increases, that means this will also increase as well. So this is for November. So we see the similar trends. So there are attacks from malware sites and phishing, but now the attacks rate is much higher. So now for malware side we had 135 million, and for phishing we had 168 million, which was only 48 million in the last month. So this is November. In December, we had phishing over 350 million. Okay, so which was only 168 in the last previous one, and we see similar trends. So if you compare the other attacks, they're actually very nominal compared to these 2 attacks. So most of the attacks are coming from these 2 types, malware sites and phishing. So in January, we see, this is also interesting. So we see very less amount of phishing in January, but there is a hike in the malware sites. So we have only 400,000 for phishing, but over almost 1,000 million of malware sites attacks in January. So in the recent month, in the last month, we see similar trends. So we are seeing 87 millions in millions of attacks in malware sites, but again less amount of phishing in other categories as well. So from these 5 months of data, what we are seeing the most dominant type of attack that are coming into the system is malware sites and phishing. And if I also want you to look into a little bit on the left side, this is called Botnet, because that is what our project is related to. So in October, we detected 5,600 botnets. Then it was even lower in the 315 in November. Then December, it went up. So because in December we had a lot of data, so it was over 600,000. Then we got reduced again to 490,000. Then again we have a very small amount in February, which is 1,800 only. So, so this is also another thing that we can detect very less amount of data. So it doesn't mean that there is no botnet. It just means that botnet could be very difficult to detect. And in some cases, when they detect botnet, mainly they detect the communication patterns. So if there is a new communication pattern, they may not be able to detect that. So this is the overall comparison for the 5 months. So as you can see, there is the dominant part is the phishing and the malware sites that is blocked by default. So this is, we wanted to look into, in particular, we want to look into malware sites. So this is for 5 months. So we wanted to check whether there is a daily pattern that the attack, something like the attack is launching in the same day every month. So unfortunately, we did not find anything like that. So there is something in the middle of the month. So there is a huge spike in January. So other than that, so there is a random amount of attacks almost every day. So there is very hard to find any correlation of attacks from this data. So this is for phishing. So here as well, we see it's very high spike in the December. And we have, in November, we see some spike of data. But compared to that, in other months, the phishing amount is very less compared to other months or other days of the month. So in terms of botnet, so as I told you, so you have a spike in January. So in January, the system detected over 1 million in a particular 2nd of January. Apart from that, so there is a very few attacks on botnet that was able to detect it. So that is one of the things that we are not able to detect very large amount of botnet transactions using CESS. So except the block traffic, there are other threat was also detected by the reputation filter. So these are other types. It's called there's gambling, there is child abuse content, there is illegal activities like illegal downloads or copyrighted data. There's some hacking attempts like port scanning, all those things. There are also some data was detected as pornographic data, and also some data related to weapons. So basically, they classify it using the source IP as well, and as well as the source of the source IP address. So these are the threat types detected in 2019. So in terms of malware categories, we have like other types of malware that is almost 32,000. There is also virus that is over 5,000. There is password PUA attack, where you try to get user access, root user access to a system. So those kind of attack. So over 2000, there's also some encrypted file attack as well. So these are the category for October. Then in the November, we saw similar trend. So we had virus attack, PUA, and encrypted files. But here what we are seeing, the other malware types, that is increasing over different months. And in January, there is a huge increase in other malware types that is detected in the system. And this is the latest data for February. So in February, we have a virus attack compared to the other attack. So in February, we see a spike in a virus which has over 150,000 virus. So that is one of the new things that we got in last month. Okay. So this is the trend for combined. If you combine all those things, so this is malware over different days. So we have a malware spike on the 4th October and other days. So the reason for looking into this, we're trying to find a pattern, whether there is a correlation in launching the attack, whether they are launching it in a particular day or a specific day. So this is, like a zoom version of that. So if you remove the attack on the 4th October, so we can zoom into, there is actually, we cannot see any particular pattern that this is how the attack is happening. Okay, so this is for November, December. So December we see a attack in the beginning of the month. And in January there is an attack in the middle of the month, like on the 10th, and also on the 8th. And in February there is a virus attack at the end of the month, so which changes the whole behavior. So the whole month is almost flat, but at the 27, 28, there is a huge virus attack came into the system. Okay, so this is for the 5 months. So so because of the spike in January, so which was a huge spike, the other line actually flattened, but we received different types of attacks in every month, as we showed in the previous slides. So in terms of virus trends, so I think every month there is we have attacks in terms of virus. In October we had virus, and also in January we had virus attack as well. So this is the virus detected. So so in February we have a huge spike compared to the other month. The virus attack was very smaller compared to the other types. So PUA is almost very similar in all the months. So there is always a similar amount of traffic that is trying to force in the system, trying to steal the username password or trying to get SSH root access. So PUA attack is similar. So we saw some attacks in January or October, but not much after that. So this is, we tried to find out whether we can identify the specific malwares. So this is what we can detect. So these are the top malware that was found in the system. So most of the malware is called VVS inord. That is one of the virus that we detected. There is a Trojan. There is most of the malware that we detected. As you remember, the major attack that we see is a malware site, and that comes from mal.gen, and they have different versions. So it has JJ, IX, KD. So from the same malware, we have different versions, and from that we see most of the attacks. Okay? And also we see different types of virus as well, which are Trojan. In some cases, these are malicious behavior. The first one was detected as Visual Basic virus. but mostly, I think most of the attack that we see was in the category of malgen. We also saw some coin miner. So you know that there is a Bitcoin mining malware that existed. So they try to get access to the system and use the resource to mine coins. So there are different categories of coin miners that was also found in the system. So in terms of major threats, as I said, so 70%, 77% of the malware, they are actually from mal.gen in this category, mal.gen. Even IX, this is the most. We also had mal.gen JJ in 4%, and VVS Inor we had almost 12%. So these comprises the most of the attacks or threats that comes in. So this data is from October. So for October to December, we see similar trends as well. So 78% is from mal.gen, and we see some other VVS Inor. There is also app, the minor attack as well. Very less, I think 7% in total for the 3 months. So this is in terms of malwares, what is the daily trend for 1 month. So if you can look at the malgen IX, so this was the attack that is used repeatedly over and over. Okay, so we can see that attack coming in different days of the month. VVS Inor comes only once or twice in every month, but we see the similar trend as well. So the malgen, that malware is being used over and over repeatedly in every month to attack the system. So this is November. As you can see, the pink line, so that is for malgen. So that is dominant part of the attack. So this is for November. So as well, we can see the malgen is the dominant part. So in January as well. So in January, this is the very dominant because we had a huge attack in January and over 10 million. So, and this attack continued for almost 5-6 days. So that actually, flattened the other lines or other attacks in the system. So in February, as I said, we had less amount of malwares. We had virus attack, so which is actually a Trojan called FujiFgen. So at the end of the month, that attack came in, so which caused a huge spike in February. So in other days, it was almost very less. Okay, so this is something also that, as I said before, so if any score less than -6 to +6, it will be scanned again. But we saw some difference in the system. So if you look at the right red line, so one of the packet was detected as malgen JJ, but reputation score was initially -9.5, which is very good. Okay, so what it means, it's possible that some of the attacks actually went through, but over time the system learned this is actually an attack. Later on, the reputation score is actually decreased. So that means it is also possible. It's not like it's not a fixed value that for every scenario we'll get the same score. It's not like that. So over time it is adapted, so that the reputation score will change based on the properties and based on the attacks that we see into the system. So let's look at some of the geolocation that the attacks is coming from. So these are the top 100 locations that we are able to locate using IP address. So basically, this location is using IP address mapping to geolocations. So assuming that the IP address is not faked, okay? So if during the attack, if the IP address is faked, this geolocation will not work. Okay? So we are assuming the IP address is not fake. So assuming that we see 100 geolocations here. So if we summarize, this is from October. So we see a lot of locations in China, some are in Europe, and some are in the United States. So we see in the November to January, again we see China, Europe, and US. So this is for the 5 months. So we tried to generate a adaptive graph. So showing the most red means there is more attacks from these locations or from this particular country. So as you can see, the China, US, we have the most of the attacks are coming from these countries. So there's also attacks from Russia, and also there is a lot of attacks coming from Germany and France. So there's some attacks coming from different Middle Eastern countries as well. And also there's some attacks from Australia and South Africa. Okay? So what, in terms of, if I look at the actual data, so majority of the data attacks is actually coming from 4 countries or 4 or 5 countries. So in our scenario, in October, we saw France, China, US, and Russia. They had almost 70% of the traffic coming in, 80% of the traffic coming from this country. And other countries has a very small amount of data. So in November to January, we see similar trends. We have attack new, so Germany increased as an attacker, but we see China, Russia, and United States in the list as well. So what we'll do next? Okay, so in terms of, we're continuing our data collection process. So we have until, I think, June or maybe even July, so we can collect the data. So we also collect the data from Education Institute. So our plan is to anonymize this data, and we'll share this data with our stakeholders from different NRENs or different education institute for future research or future analysis. Okay. So to conclude, so what we learned from this establishment is that it is very challenging to provide cloud-based security services because of the very high infrastructure requirement. Okay, so if you have a very large institute, you also need a very strong infrastructure that can handle the huge amount of data coming in and going through the system. Even the Cisco, which is a very high-ranked company and software, even that we saw it cannot handle when the data is too much. So that is one of the big concerns while designing this kind of system. So CESS can provide additional security, as I showed in different months. So we are able to block huge amount of attacks in the system. So what it means, if the CESS system was not there, that means those traffic will end up at the end users. Okay, that means the user will be attacked at the end system. So that means in terms of the idea that we can provide security in the centralized location as long as we have very high or very good infrastructure, we can provide additional level of security. This is by no means the replacement for end user security. That means end user will also still will need the antivirus, protections, all those things. But this layer can help users to guard themselves from different types of attacks. So our analysis shows around 32.2% of the data is attack data on average. That is almost 1/3 of the data coming into a system is attack data from at least from our setup. So attack escalated from 11% to 46% in only 4 months. Okay, so which was huge scenarios. That means as the system is exposed to the internet, the attack also increased day by day. Almost 3/4 of the attack originated from 4 countries. So China, Russia, US, and I think one of the European countries. So most of the attacks coming from the 75 to 80% of the data coming from 4 or 5 countries. And in terms of botnet detection, we see very low count in botnet. So that means it usually means that it is very difficult to detect botnet in this setup. So additional research is still ongoing, as you know. So more research is actually necessary to detect botnet as well. So with that, I'll conclude. Thank you very much. I'll be happy to answer if there are any questions.
Thank you very much for the very interesting data and your findings. So we have about 5 minutes. Any question? Very interesting question there. Okay, this one. Please, there is one question.
Mahmoud, I'm just curious about network architecture that you introduced.
It's very
So, architecture.
Iswar, can you stand up? We cannot zoom you well.
Well, in initial network architecture that you introduced in like TENS, so you deploy CESS in cloud, right? And then packet goes through CSS and route the gateway. Then install traffic.
Sorry, you are breaking up.
Hello?
Referring on
Your initial architecture TENS.
Yes.
Me? Hello?
Yes.
Yeah, in slide 10, you deploy CSS in cloud, right? And then it seems that traffic is rerouted. And of course, this will introduce and then you change the network in slide 12, right? So you locate CSS between router and then right?
Can you capture the Iswar is asking about the changes between the previous design to the latest designs.
But it seems that you deploy CSS dedicated hardware, right? Actually, in the beginning, right? So you are not deploying.
Yes. So that's what I was talking about. So our initial plan was to set it up in the gateway router. Okay. So that would be the the final. I think if you do into the production setup, so it should be like that. But the problem was that we only had the software from the project, so we had to use the BDN hardware infrastructure. So the only solution they had, you have to set it up in the cloud. So they have their cloud set up like this. So that means there is no way that we could set it up before the core router. Okay, that was one of the challenges. So ideally, it should be before the core router. So in that way, or maybe after the core router. So in that way, you can pass all the traffic through the system. So you don't have to do anything else. If you can pass through in the transparent mode. So, but again, So there is another mode that they didn't want to do. So it's possible to set the WSA in the core router as well. So if you want to, if you set it up in the core router, you can enable the service. So in that case, all the traffic that is going through that router, so they will also get the service at the same time. Okay, so that would be the better design. But in this case, because we did not have that option, we have to use the cloud option.
So you deploy dedicated machine, right?
Yes.
Is that any specific machine? I mean,
Sorry, can you repeat?
so the machine specification in slide.
He is asking about the implications of your implementation. Like
Whether they call one or just ordinary server.
This is not the server. So they have a cloud infrastructure. So they created a VM there. So they created a virtual machine with VMware ESXi, and we use that VMware to install the service.
Okay.
But WSA can be, according to their documentation, we can actually also install it in a core router as well, as long as the router is supports the model.
Okay. Thank you.
Okay, any other questions? Actually, okay, one. You can introduce yourself.
Okay, thank you very much, Dr. Mustafa. Let me introduce myself. My name is Aditya from Brawijaya University. I'm a bit curious about how can you obtain the web reputation score for each address consider in your system. How can you obtain the web reputation score of your access policy? Thank you.
Abbas, can you repeat the question? It was breaking up.
He is asking about the methodology of how
The web.
web reputation score.
Okay, so there is an algorithm that you can apply. So the idea is there are different properties. So it is based on the source IP address where it is originated. So it also based on which server it is coming from, and if it find out by using the DNS, reverse DNS, you can find out which DNS it is coming from. Then you can find out the DNS ownership information, how long this particular domain has been purchased in live. So there are different properties out there. So based on that, it gives this score. Okay. So for example, I think in previous lecture we talked about. So if you have a very old company, something like Google, Facebook, so they have a very good reputation score because their establishment will be very higher up. They have a very good security policy in their system. But when you say if you yourself set up a server and you start launching the service, reputation the score will be lower because of the time period that you have. Even though you may not be sending any malwares and anything, because of the time period, your reputation score will be lower. And also there is a global database for every domain as well as IP address as a source of malwares, source of spam traffic. So if the IP is belong to one of those blacklist database, that means the reputation will also go down very highly. So all those things actually are used to create the reputation score.
Thank you for your answer, but I have one question. So if you in the web reputation, And let's say we have a case that we distribute the malware through WordPress.com, which is some blog there, then we distribute some malware, then we detect it as a low score. You get my question?
Can you repeat again?
Okay, let's say if you get the score based on how long the domain exists in the internet. So how if have a case that I will distribute some malware through a blog page I created, let's say WordPress.com. It's a quite long.
So you're saying you'll set up a server for malware?
Yes, I set up some blog to distribute some malware, so it will not be detected as a low score.
So yes, so it's possible that initially you may have a high reputation score, but once, say for example, once the packet is detected, it could be for the second level, because in the second level between -6 to +6, so we scan the packets, right? So even though by the reputation you can pass through first level, so by scanning the packets, so they can further detect whether this is a malware or not. So in the second level, it can be detected as a malware. In those cases, so that reputation score is adaptive. That means even in the first time, you can have higher score, but once the source is tagged with a malware coming in, the reputation score will continue to go down as you have more traffic coming in.
So it's just like what is in the slide, malware gen AJ, become 9.5, and then the second round or second level clean up, then it will lower. Is that what you mean?
Yes.
Thank you. There are any other questions? Okay, you from the question.
Yeah, thank you very much. Very interesting. Ask about maybe second question. This for the second WordPress, I would like to ask about what about if one of our domain website in our institution. So, according to our experience, sometimes there are some websites indicated that the website is very vulnerable. So there is maybe ransomware, maybe JavaScript for mining errors. Just you said before, the scores can be already that for our institution. So I think others using your services going to our, I think it will be. So is there any how can we pull out? I mean, release our domain. So I think if we ban one system, maybe it will be on the core. If we don't care about the type our thing. So how about one more question? In our research campus in Lampung University, last year we have many cases. So a computer industry going to very low in working process. We see the process that, as you said before, already running to monitor. So if you give us some clue can we prevent this security. students. And you can tell us for layer 7 and then check layer 3 or others. You can solve the problem by installing the Windows. Thank you very much. Okay. There are two questions. Maybe the first one is related to the case in the university. The second one is related to the suggestion.
So Abbas, I think it's a little bit breaking up. If you can summarize the questions. It's a lot of breaking up.
The first one, have you any manual method?
The other microphone may be a little bit clear. This is breaking up a lot.
Can you hear me? Okay.
The other
Okay, a simple question is like this. In this, relay like this, we have a procedure to release our request for the blacklist from the server. Is in your system supporting procedure like that, or on system application? Just wait and see. If score is bad, you ignore, and then if score is better, and then it's okay. That's one. Is there any method? The second one is how to find out. So, okay. So, I would like to summarize this the way how we need the blocking. Somehow, this web is supposed to be good, but somehow it blocked in your system.
Well, yeah, it's possible. So, as I said, so if it is, so in general, what happens? The reputation is scored generally in the middle. So even if you are a new school or new company or new IP address, so it will not be like in the block, like less than -6. Okay, so the reputation score is designed in a way so that in the first you will not be blocked, even though event could be if you are a malicious site. Okay, so it's very unlikely that you're the first time user, you don't have any malicious data, and your reputation is scored it's below -6 and it's blocked. It cannot pass through. So the reputation score initially it is in the middle sign. So initially, if it is like I think around 0, or even in the positive side, it goes down once the malware is starting detected from your system. So the negative means you have negative impact. So it could be from malware is originating from your system, or spam is coming from your system. So all those things will actually putting into the equations. Okay, so as a new users, so our reputation score will be initially at the initial level, it will be very close to 0. Then as time goes on, depending on the global database, so if you are blacklisted, then reputation score will go down over time. Okay. For example, if you're sending malicious packets or spams every day, right? So as you are sending more malicious data, the reputation will score go down. But if you fix, for example, you had a problem in your server that allowed the attackers to use your server to send the malicious request. Okay, if you fix that service, then reputation will go up over time. Okay, so this is a continuous process. It's not like, it's very unlikely that you are a valid user, you don't have any malicious traffic, but your traffic will be blocked. It's very unlikely. So it starts at the middle, and once you start sending malicious packet, it will go down. If you fix your problem as a valid user, it will go up again.
Nice. That clear enough? Thank you very much. So, one more questions.
Okay.
It's very interesting. Actually, I'm also having a question. We saw attack from Indonesia. Actually.
Thank you, Professor. Okay, as you know, uh, the system, the Botnet, uh, the system is for traffic HTTP and HTTPS, right? So, is it mean that the Botnet is only running with for 180 and 143, or is there another method?
So you're talking about why botnet is
Network.
lower?
How the Botnet, is it only the Botnet it's run
So usually it is very difficult to detect botnet because virus, when we say virus or malwares, we can see a pattern of packets that this packet or this pattern is available in this data packets. Okay, and there is a global database that is shared by the security companies. So they share data which IP address or which users that is originating those malware traffics or not. So in terms of botnet, it's difficult for two reasons. One is the end users, they do not know they are part of the botnet. Okay, so there is the botnet we call the command and control that is very stealth, that is like one node, but it has many bots, and the bots basically they do not even aware that they are part of the bots. And the communication that is going on between the different bots and botnets is it's very difficult to get the pattern. So if you do not have enough data of a particular botnet, so it's very difficult to detect that particular botnet. So that's why as I said, so we see very low count of botnets, mainly because it doesn't mean that there is no botnet. Even it's possible that your laptop is part of the botnet because someone is using that laptop as a miner, but if you do not even know about it, and your antivirus software cannot detect it because there is no real pattern on how it works. So usually it's very difficult. So there different research usually takes a lot of coordination to detect a botnet attack.
Enough, I think, because it's time for us to have a late dinner. Thank you very much, Dr. Asif. Let's give applause to him.
Thank you very much. Thank you very much. Bye.
Thank you very much. Okay, wassalamualaikum. Baik. Baik,